Let us now take a look at a program where we are going to do the transpose of a matrix. First, let's understand what is transpose of a matrix before we end up going and taking a look at the program. In transpose of a matrix, the resulting matrix happens to convert rows to columns and columns to rows. If you take a look at this, the first row is 1, 2, 3. Next row is 4, 5, 6, 7, 8, 9. So if I have to do a transpose, okay, I am representing it another matrix B, although in thing we do it differently in maths, but I am representing it another matrix B, where if you see the first row has become the first column, 1, 2, 3. Second row has become the second column. Third row has ended up becoming the third column. So this is what you really mean by transpose of a matrix. Now, in order to solve this problem using a C++ program, we are going to make a few assumptions. The first assumption is we are assuming it's going to be a square matrix, that is 2 into 2, 3 into 3, 4 into 4, 5 into 5 and so on. If you want to do it for different size of matrix, it's not difficult. There's a small change. I'll just let you know when you want to actually do it. First, what I'm going to do is, let us say I enter the values of m and n. Okay, so m happens to be 3 and n happens to be 3. All right, so m is the number of rows, n is the number of columns. So if you see this is a 3 into 3 matrice. Then what I'm doing is I'm reading in the elements of a matrice. So we have already discussed how we read objects or elements into a matrice. So I am reading 1, 2, 3 in the 0th row, 4, 5, 6 in the first row, 7, 8, 9 in the second row. Now, in order to do the transpose, the result of this transpose, I am putting it in another matrice called as B. So let me show you this matrice B here. So B is this resulting matrice. This is 0th column, first column, second column, 0th row, first row and second row of the matrice B. So I'm changing the color to blue so you can see that all the values as we are going to dump into this matrice B as we run through the logic is going to be pretty clear. Now, in order to convert rows to columns to rows for a square matrice, you just need to interchange the value of these subscripts. Ij becomes B of Ji. So let me show you how it is done. Just as we are going to print a normal matrice, you are going to use the same logic, except that A of Ij is assigned B of Ji. So let's start with the value of I is 0. 0 is less than 3. J number of columns is also 3, so we come in. J is 0. Okay, 0 is again less than 3. Now B of Ji, both are 0. I is 0, J is 0. So he is talking about this position. So 1 comes as it is in this particular position. Now what I am doing is I am increasing the value of J by 1. 1 is still less than 3. Now B of Ji, that means now he's talking about first row and I is 0. First row, 0th column. This fellow is going to contain A of Ij. A of Ij is this particular fellow because I is 0, J is 1. So first row, 0th row, first column is going to be this fellow. So this fellow is going to come. So look at the value here. This is representing J. Okay, this is representing J, this is representing I in the matrix. So when J is 1 and I is 0, 1, 0 is going to be this fellow. Now I am increasing J by 1, it ends up becoming 2. 2 is still less than 3. P of Ji, J is going down like this in the transpose matrix, I is going like this. J is 0, so 2 is here, 0 is here. So 3 ends up coming here. Now I'll increase the value of J by 1. It ends up becoming 3. 3 is not less than 3. So I go here. I is increased from 0. I becomes 1. When I becomes 1, J is back to 0. Okay. When J is back to 0, 0 is less than 3. I am coming here. Now 0 of I is 1. 0 and 1. This is 0 and this is 1. So I am working on this position. A of Ij, 1, 0. 1, 0 is this particular fellow. So 4 comes here. Now again J is increased by 1. Once j is increased by 1, it is still less than 3. Now 1 3 1, and both are 1 and 1. 1 and 1 refers to this point because the value of j is 1 here, the value of I is 1, so I am referring to this point. A of 1 1, a of 1 1 is also this particular first row. This is zeroth row, first and second row. So first row, first column is going to be 1. Sorry, this is going to be 5. Okay, so this is going to come here. Now what I am doing next is I am increasing the value of j by 1. It becomes 2. 2 is still less than 3. B of j is 2, so I am referring to this particular fellow. I is 1. 2 1 is this particular point. Now I is 1 is this fellow, and j is 2. 2 refers to 6, so 6 comes here. In a similar manner, these numbers 7, 8 and 9 are going to be filled up in this particular loop. So make an effort to draw a matrix and run through this. In case you want to do it for a non-square matrix, just interchange m and n. Where there is n, you put m. Where there is m, put n. And you should be able to get the transpose of this matrix. Then it is quite easy. I am going to print the transposed elements using this for loop for I equal to m, j equal to n. And here if you see, I am printing I and j. So if you see, after printing each line in the inner loop, I am having this end line. So after it prints 147, it automatically takes the cursor to the next line. Then it takes 258, and then the cursor goes to the next line. I have already explained this printing process, so we will not try to revisit that and bore you with a long lecture. So this is how you do the transpose of a matrix. Make an effort to run through the logic by creating a table of variables, output array. First understand it conceptually and then do it. It's a real simple task.